Hello guys, welcome back to the new session of Digital Electronic and Logic. In this session, you are going to learn about Boolean Algebra. So without further delay, let's get into the session. So this session agendas are, we are going to talk about Boolean expression. We are going to see types of Boolean expression. We are going to see Boolean algebra and few exercises. So let us see what is Boolean expression. A Boolean expression is composed of combination of Boolean constants, true or false, Boolean type variables, Boolean valued operators, and Boolean valued functions. Let us understand this definition of Boolean expression using this an example. So I'm writing an example a plus b dot c. So where a and b, a, b and c is Boolean typed variables, where plus and dot, plus is a OR operation and dot is a multiplication like AND operation. So this plus and dot is a Boolean valued operators. Let us see the next example. In this example you can find 1. So 1 is a Boolean constant, true or false. So here is a true 1. So a dot bracket b plus 1 bracket closed. So this expression is also, so you can see the Boolean expression consists of the Boolean constants true or false, Boolean type variables, Boolean value operators, and Boolean value functions. So this Boolean expression will be evaluated. So once you evaluate this Boolean expression, produces a Boolean value as an output when evaluated. So once they produce an output as a Boolean value, so the Boolean value can be true or false, either 1 or 0. Let us see the types of Boolean expression. So types of Boolean expression we have is two types of Boolean expression. So one is called the SOP. SOP stands for sum of product. Another one called the POS. POS stands for product of sum. Let us understand this SOP and POS with an example. So you can see the example A dot B dot C. It can be also called ABC as a product. So this is a product term. Plus AC, A dot C is a multiplication. Dot is a multiplication and operator, or we can say and operation. So AC plus BC. So this product term ABC is a product, AC is a product, and BC is a product. It has been summed using the plus. So that's called the sum of product. Let us see the another example of POS. So POS, you can see the product of sum. So you can see in an example A plus B plus C. This is a sum term. Multiply, you can check on the pointer, A plus C multiply B plus C. So A plus B plus C is a sum. A plus C is another sum term and B plus C is another. So it has been multiplied, nothing but product. Product means multiplications. Okay, so this is a product of sum. These two different type of Boolean expression we have it. Let us see what is a Boolean algebra. So basically the Boolean algebra is used to analyze and simplify the digital circuits, the digital circuit design that you have designed. It uses only the binary number 0 and 1 because of digital circuit is 0 or 1. So this Boolean algebra was invented by George Boole in 1854. So there is a rule in Boolean algebra. So when you see the complement of a variables, any variables like A, B, C is represented by an over bar, like a horizontal bar you can see in the bracket. Thus, complement of variable x is a variable is represented as x bar, x above bar. Thus, if x is equal to 0, then x bar equal to 1, because x is equal to 0, x bar means x above bar is not get. Bar is used to negate, complement the input. So x is the input is 0, then because of this bar complemented the input become 1, and if it is 1 then it's a 0. Oring nothing but or gate. Oring of the variables means when you are adding, doing the a plus b, b plus c, x plus y, something. Oring means plus, is represented by a plus sign between them. For example, oring of abc is represented as a plus b plus c. Then again logical ANDing. Logical ANDing means AND operation, multiplication of two or more variables is represented by writing a dot between them, such as a dot b dot c. Sometimes the dot may be omitted, can be removed, eliminated, like ABC. ABC is a one product, A product, B product, C means A times B times C. So ABC. These are the rules. When you look at the Boolean algebra, you will find it. So let us see why Boolean algebra. As I have explained also, it is used to analyze, but still let's see. Why Boolean algebra? Basically the Boolean algebra is used to simplify, analyze complex, tough Boolean expression or equation. How it happens? So we have a different kind of Boolean laws, Boolean algebra laws. So we select those Boolean laws, and rules are when we apply step by step to the given original equation or expression, so that eventually arrive at a simplified version that can be implemented with a smaller number of gates and therefore lead to a simpler circuit. When you are given to the complex Boolean expression, you need, when you are going to design a logic circuit, it will be very big. But before designing the Boolean expression with complex given Boolean expression, you can simplify those complex Boolean expression using Boolean algebra. So what will happen once you simplify the task that can be done with the big Boolean, complex Boolean expression, same task can be done by using the simplified version of Boolean expression. So basically the Boolean algebra is used to simplify given complex Boolean expression or equation. So let's see the law. The Boolean algebra law. The Boolean algebra have a different laws. So first one, order doesn't matter. Okay, so I have arranged in this order, so read in this order. So it is not called the first law. Okay, just it is a law. So law means a plus 1 equal to 1. So a plus 1 equal to 1. So if you find in the given Boolean expression and you want to simplify, so you can apply these laws. So whenever see any Boolean variables, a plus 1, b plus 1, c plus 1, anyone, equal, the resultant value will be 1. How? Let us understand with the truth table of this. So because of plus, we are going to do the or operation that you have seen the rule of Boolean algebra. So a is a Boolean variable of given Boolean expression here rules. Now if a is a 0, a can be 0 because it is a variable, and then plus 1, so another one is a 1. What could be the output? It is output is 1. So 0 plus 1 is 1 as a OR gate. Again a can be 1 because of this is a variable, but plus 1 is a constant, it is a Boolean constant. Okay, so 1, so 1 plus 1 is again true, so true. So that's why we can say a plus 1 equal to 1. So when you are simplifying the Boolean expression, you can apply this. So wherever you find a plus 1 or a plus b plus 1, something like this, means when you are ORing any Boolean expression with 1, it's a 1, output is 1. Let us see the second rules. A plus 0 equal to a. How it happens? So let's see. Still it is a plus operator, so is OR operation. So OR, I am going to do. A is a Boolean variables and 0 is a constant, false. So we can say a can be 0 and constant, 0 is 0. So 0 plus 0 is 0. So check it out, 0 plus 0 is 0. So what is the value of A? A was 0. A was 0. What was the output? 0. So A plus 0 equal to A. So whatever input was there, because the plus is 0, so A was 0 and output is also 0. So A. Let's see the 1. 1 plus 0. 1 plus 0 is 1. So you can see what was the input? A. What is the output? Oh, sorry, what was the input? A. 1 for A. What is the output? 1. So whatever input is there here, so A, whatever you are passing A, the same output is coming. So A plus 0 equal to A. That is law, you have to remember. Let us move to the next one. So another called the A dot 1 or A1 multiply. So dot means AND operation. Okay, sorry, it's mistake here, it's AND, okay, not OR. So you can just ignore, because I'm recording this video, so I'm not going to terminate. So it is a AND, not OR here. You can see the pointer AND. So A is a Boolean variable, so A is can be 0 and times 1. 1 is a constant Boolean value. So 0 times multiplication 1 is a 0. Okay, so what was the input? Input was A is 0 and output is also 0. That's why we can say A times 1 equal to A. Now again input is A is 1 and 1, this one is a constant because of this Boolean expression. So I'm just justifying the rules, the laws, why A times 1 equal to A. So 1 A. So what was the input? A for A it was 1, output is also 1. So you can see whatever input you are passing, that is the one as output is coming. So we can say A times 1 equal to A. Let us see here, we talk about A times 0 equal to 0. As we know that even we don't go through the truth table, we can say if you multiply any value with 0, it's always result is a 0. But still we can say, again don't mind, this is not OR, it is a AND. Okay, not AND, because I copy paste, I forgotten to change this one. So okay, fine. So 0 times 0 is always 0 and 1 times 0 is always 0. So as we know that 0 is a destroyer, it can destroy when you multiply with 0 any number. Let us continue with another law. A plus A equal to A. So A plus A equal to A. Since it is a plus, so this is a OR operation. So A plus A equal to A. Let's see how. You can say 2A, not A, because true or false. So if A is 0, then this A is also 0. So 0 plus 0 is 0. So whatever A, and same thing is coming as A. If A is 1, so because of A plus A, so another A is again 1 because A is A plus A. So again output is 1. So whatever input is there, same output is coming. That's why A plus A equal to 1. Let us say A times A equal to A. So this is not OR, it is AND because of this dot. So 0 times 0 is 0. So whatever 0, it was A was 0, output is also 0. A is 1 and A is another one is A. So 1 times 1 is 1. So that's why we can say whatever input you are passing of A, same is output is coming. So this rules A times A equal to A is a law. So I'm justifying the law. Okay, how to cram. Now let us see the next law. A plus A complement equal to 1. A plus A complement equal to 1. Let's see how. So this is because of plus, we can say it is right here, or so A. So A and A apostrophe, you can see here, it's a kind of complement. Okay, is a, we can write over bar. We were talking about in the rules. Okay, or we can talk about the apostrophe. Both are complement. So if A is 0, then because of A complement, it can become 1. So 0 plus 1 is 1. If A is 1, then because of this complement, it can become a 0. So A plus 1 plus 0 is 1. So that's why this rule is true. Always is 1. Doesn't matter whatever input of this, because A plus A bar equal to always true, 1. Let us see the 8 multiplication. So A times dot. A times dot is multiplication dot. A over bar equal to 0. So why it is 0? You can see is wrong here, not or, it is AND. So fine. So A can be 0. Then because of A over bar is 1 because of complement of A. So a was 0, it become 1. So 0 times 1 is 0. Then if a is 1, then a bar will become 0. So 1 times 0 is 0. So this true is also right. Let us continue to the next, called the a double complement, or we can say a double bar over bar. So a double over bar is a. Why? Because double complement. So let us understand. A is input, then we can do the one complement, then two complement. So if a is 0, then one complement is 1, then you are complementing the complemented inputs become 0. So what was the a? It was a 0. And what is the output? A. So a over a double over bar or double complement equal to a. Again, a can be, if a is 0, okay, a can be 1. So if a passing 1, because of one complement, not 2 at a time 1, so it become 0. Again you complement, because double complement, then it become 1. So what was the input? It was the input a and getting the m. That's why a over bar equal to a. Double over bar. Let us say this is also known as a complement law. This is also known as a complement law. Fine, let us see a different rule called the commutative laws. So commutative law is a plus b can be rewritten as a b plus a, just in reverse order. And a times b can be rewritten as a b times a. That is called the commutative laws. Called the associative laws. So associative laws say a plus b bracket plus c can be rewritten as a plus b plus c. It is the same. Is a mathematical rule, we can say. It is a part, you would have studied this law in mathematics. So associative law here also, a times b times c can be rewritten as a times, okay, b times c. Here can be bracket here, here can be b plus c bracket here. Let us talk about another rule called the distributive laws. Distributive law, distributing, factoring. So you can see a times b plus c. So it can be multiply a times b plus a times c. So that's why a times b plus a times c. It's called the distributive law. Another called the a plus b times c. So we can multiply with bc can be multiplied with, so we can say here a plus b times a plus c. It can be done. This is a distributive law. We see how it can happen. Okay, this is another laws. We can say a plus b c equal to a plus b dot a plus c. You will see this exercise how to derive in an exercise. Let us see another called the De Morgan's law. We have a De Morgan's law. There is two De Morgan's law. One called the a complement plus b complement. You can see separately it is a complement. A complement separate plus b complement can be a times b. A times b product of ab over bar. Over bar is not separate. Keep in mind, it is over bar in full. So this called the inverting the inputs. Inverting the inputs means negating the inputs to an OR gate, or because of plus is OR gate, changes its function to the NAND gate, because you know the a times b is a AND gate, and because of over bar it become a NAND gate. So that's why it's going like this. Let us talk about second law. A over bar times, check it out, here was a plus, here is a times, then b over bar equal to a plus b over bar. So what is it? Inverting the inputs to AND gate. It is AND gate. Check it out. This is inverting inputs and times is AND gate. Change its function to the NOR gate. Why NOR gate? A plus b is a OR gate, and because of over bar in a whole expression, is called the NOR gate. So this is a De Morgan's law. Fine. So those was a Boolean algebra laws. Fine. So let us see an exercise. See. So exercise I have brought for you is this one. Randomly I have written just. So a dot means a times a plus b plus c bracket close plus a. So apply Boolean algebra that you have learned so far to simplify this Boolean expression. How to do it? So I am going to explain. So let me write down. So I have rewritten this Boolean expression with a smaller space to understand for readability. So how to do it? So I'm going to charge this one first. So you can see this is the same I have written. So I can multiply a with a plus b plus c. So I can take at a time this one up to this one. So I'm going to use this one. So what we can do? I'm going to use the because of distributive law. You have studied the distributive law. So I multiply a with a. So a times a. Then a times b. That's why plus ab. Then a times c. That's why plus ac. Because of distributive law. So this is a law. On what law? What law did you apply? Because we have to apply the Boolean algebra step by step in order to simplify the given complex Boolean expression. Fine. So this the one you can see the selected one. This one I'm using just for emphasize purpose. Okay, emphasize purpose for the rounding one. This is the one I'm selecting. So this is the one. So I applied the distributive law. So I'm this one. Now let us go. I'm going to target only this. Only this. You can see the target. So I can see I have done a times a. A times A is A. You have seen in the laws, Boolean algebra laws. So I use the since A times A equal to A. So this can be rewritten as A times A is A. So I have written. Now again, I am going to target this one. And I am going to apply the distributive law, common factor ought. Common factor ought. Distributive law, because A is here, A is here, A is here. So I can take it A is ought. So A times 1, because of A is only 1. So 1 plus B plus C plus A. So because of common factor ought, and it's also known as a distributive law, because we are distributing. Now I am going to target this one, a 1 plus b plus c. So I target the 1 plus b plus c. So we know that there is a law, identity law, called the a plus 1 equal to 1 or c plus 1 equal to 1. So if, keep in mind, if you are ORing, plus means if you are doing the addition 1 with any number of variables, the output will be 1, because you have a 1 is 1, so because of true and false. So 1 plus b plus c, so b can be 0 or 1, or c can be 0 or 1. So eventually this is a true. So output will be 1 times 1, a times 1 plus a. This a is here. What is the row? Since 1 plus a equal to a, so we can say 1 plus b plus c equal to a. Now we can apply a times 1. This is another Boolean algebra. So we can apply, then a times a is, because since a, sorry, is mistake here. Okay, not mistake, because of this a times a equal to a times 1 equal to a. So I have written a. I'm sorry here, dear students. So a times 1 is a. Exactly, yeah, it's true, because a can be, you can take the reference, you can look up at the Boolean algebra tables, a times 1 equal to a, because if a is 1, output is 1, if a is 0, output is a 0. So a, fine, true. I'm just revising the rules. Okay, so now it is a plus a. So now we can go a plus a, and we can say a plus a equal to a. So this is your simplified Boolean expression of this given complex Boolean expression. So hence we can say simplified Boolean expression equal to this equal to a. So this expression, you can see an example, can be rewritten as a only a after simplification. So see how many gates your circuit has been just simplified. Because to design this Boolean expression, you need one OR gate, 1, 2, 3, 3 might be NOR or gate, one AND gate or buffer gate, blah blah. But here only using the buffer gate it can be done the same task. What is the output of this, and same output can be done here. So this was a simplified Boolean expression by applying the Boolean algebra. So when you are simplifying the given Boolean expression, keep in mind this you have to write beside the law that you are applying. You can see I'm writing what law did I apply to get the next step. So that's why I call the apply the given Boolean algebra step by step to given original equation to simplify the Boolean expression. Fine, I have another example for you. You can try. So this is a distributive law. You have seen the distributive law, second distributive law example, something, no, commutative law. Okay, you can see this one. So we can do the same thing, a plus b times a plus c. So a plus b times a plus c, you multiply, distributive law, then you will get this one. Then again you apply here a times a, you can see, then you get a times a, then because of the, you can have written the laws, then a, then this can be a distributive law. A is common of this one, a is common of this one, you can take it out, a 1 plus c. So it can be written as a plus c. So a plus c is also 1, so that's why a times a, then plus b. So a, this can be cofactor again, it can be written a times a dot 1 is a, so I'm taking a is a common factor, so become a plus b. Then this can be written as 1, so a dot a, then it can be written as a, so a plus b. So we can say, here, hence a plus b dot a plus c equal to a plus b dot c. This is one another law. So whenever you're finding this kind of expression in given Boolean expression, you can rewrite directly as a law. You can see in the law I have given this expression. I'm going back to show you in the one laws. Let me go faster just to show you the laws. It was here. You can see this law, distributive law. You can see this law is here. So this law I was talking about. So fine, so we have seen two. Let me go faster, that because I went back and I have animated the lesson. So let me go back. Okay, so this was the next lesson. Okay, so that exercise, thank you, and please, I would like to request you to watch this video, pause, rewind and listen, and try to find the more Boolean expression and try to simplify by applying the Boolean algebra. Okay, God bless you.